Good day guys, being here. So today we're going to try this one. Okay, so we will need a hexagon pattern, but we know that if we use the hexagon pattern in the pattern-based family, it's not perfect. Previously we did this one. So if you search hexagon in my channel, so you should be able to find this exercise. So it's 2021. Yeah. So you probably just search perfect hexagon pattern. So if see these are the perfect hexagon. Okay, so and we will need to use this one in today's exercise. Okay, so let's just download this one, and also yeah, so let's start. I'll just leave it here. So I will just load this one into the new family later. So first we can choose a, so we can either use adaptive family or just conceptual mass. Let's just use like a conceptual mass. Okay, so first I'm going to just place a point here, use draw on world plan, I'll place it in the middle. And then just place another point, draw on world plan, and place onto the point. Oh, hang on. Again, draw on world plan, set world plan, tab, and place. Okay, select the point up. So this will be the height. Okay, so we can create a parameter. Let's call it overall height, h maybe. Okay, so maybe just let's make an instance parameter. Okay, so now we have this, right? So and then we can place, let's just maybe change this one to always show reference plan, so it's easier for us to place reference plans. So now I'm going to just place a reference circle, draw on world plan, set world plan, pick this horizontal world plan, and place this. Create a radius, let's call it radius r, instance. Okay, so now this will be the size, so you can see the overall size. So we're going to use this radius to control it. Okay, so and then we're going to create a form, use this circle. So now let's try that tip again. So if you use keyboard up and down, you can switch between different options. Alternatively, if I escape, you can always zoom out, and then you should be able to see these two options. Okay, so two options. So now select the one, only the surface, and then we can use divided surface, select it, and change this one to a hexagon shape. So this one's currently, it's not perfect hexagon because the relationship between the grids are not quite right. So what we're going to do is we go to this family, tab, select it, edit family. So this is the pattern based family. Okay, so now let's load this one into the new family, and then select this pattern based divided surface, and then we can just change it to this. And still we need to adjust the grids a little bit. Okay, so currently it's all fixed number 10 by 10. So we're going to use a fixed distance and fixed distance. Okay, and then the relationship between these two number, I'm not sure, I can't remember. Let's have a look. Okay, here, so we have, what do we have? So one is, okay, so let's have a look in family types. So okay, so this is the formula we need to match. So basically one, if we have x, edge length, oh, what's that? We have x equals this, and then y equals this. So let's just control C. Okay, control C. So I'm going to create a parameter for the distance. So if I'll just have a test. If I try 2 meter for this one, and this one, I'll type equals control V, and replace the X to 2 meter. So let's have a try. Apply. Wrong. So which means it should be the other way around. So I'll Control X and type 2 meter here and Control V. Now this is a perfect hexagon shape, right? So now we just need to make sure. So if you look at this image, so see that's one hexagon in the middle, and then 1, 2, 3, 4, 5, 6, I think, and then 1, 2, 3, 4, 5, 6. So we need to achieve that amount of hexagons. So first, let's select this divided surface. So change the border tiles from partial to empty. Okay, then this one. So looks like we need to get rid of these two. So which means relative to the radius we need to increase this number a little bit. So like for example 2100. This one needs to be equals control. Equals this one divided by 2 times 2.1. So this will give us the right number. Okay, so looks like we need to, so still we need to reduce the number, so it's slightly less than this, so minus 2050. So and this one again equals Control V times divided by 2 times 2.05. let's try this. Still need to be reduced. Sorry, 2 or 3 else. Let's try that. Equals Control V divided by 2 times 2.03. Still need to reduce. 2010 equals Control V divided by 2 times 2.01. Still need to be 5. Equals Control V divided by 2 times 2.015. Still doesn't work. How about 2020 equals Control V divided by 2 times 2.02. Finally. So this is exactly what we need. Okay, so relative to the radius R, so these are the number we have. So what we're going to do is, so let's go to here. So let's just let me think. 11700 divided by 2020 equals. Okay, so this is the number we need. So maybe let's say use, how about 7921. Okay, so Control C. So go here. So I'm going to create a parameter. So we call this one what do we call this one? So it will be grid 1, so G1, or we call it V. Okay, V instance. Okay, and this one will be the U. Let's call it U instance. Okay, and go to family types. On the V, we're going to use the radius. Okay, radius. Control V. Okay, so radius divided by this. So and then I'll just type in 1 because that's the decimal number. It's closer to the actual number. Okay, so see that this gives us total 2020. So now for the U, I'll click on OK for now. So I just need to go back to that family to copy that formula. So go to family types here. So this is the formula for the U. Okay, so go here, click on this. U equals Control V. So just replace the X with V. So this will give us exactly the same number, right? So click OK. Okay. So now if we change the radius, for example, I'll change it to 10 meter. It will reduce all these, but keep the pattern. Okay, keep the pattern. Okay, so and then the next step is let's have a look. Okay, so see these skinny members. We can, I think we can just build them into here. Okay, so what I'm going to do is I'll get rid of this surface. So to place those, let me think. Yeah, maybe we build this 1, 2, 3 as well, and also the boundary. So the boundary, for the boundary, we can just simply, because we already have this one, right? So we can just uncheck the box to make them a model line. And then we're going to need a midpoint. For the midpoint, there are different ways of doing this. So let me think. So we can probably just how about we just place a midpoint, place a point, use draw on face and place a midpoint and connect. Okay, so I'll make this one a reference now because I don't want to see it. I don't want, there's nothing, line across. So, and this is only for this point, so this will be a midpoint, and then we can just connect these points. So this one, create a model line, right? So connect this one, another model line, this one, another model line. Okay, so then we also need to create all these skinny one. I think we need to have these as well, because if there's no line between these points, we can't really place any model line onto them. Okay, so let's just connect all these points with the midpoint, and this one and this one. So now we can use divided path. Okay, so 1, 2, 3, 4, 5, 6, and we can just, wrong one, divided path. So for example, this currently is 6, and let's change it to 12. So if you want to, you can add a parameter just by clicking this. Okay, so you can change the number. So now we have all these nodes, and we what we can do. So we can create a adaptive family. So let's go generic model, adaptive, and let's just place 2 points, make adaptive, create a splice through points, and this is it. So we're not going to model any form, so only just lines. Okay, so and then we can just load this one. Let me check. Let me check the name of this one. So it's family 5. So now we can load this one into family 5, and then we can just place. So actually, before place, let's escape. Let's check the number. So this one. So tick this wrong one. Tick this show node numbers. So make sure. Okay. So this is from 1 to 12. And how about this? Show. So see if I can. Yes, you can select all of them and check this box. So now we can see all the numbers 1 to 12, 1 to 12. So this one's the other way around. So we need to flip direction. Same, flip direction. Okay, so now we can create component, and then we can just place 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. And then we can select this, repeat, 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 and select this, repeat. So there is a little warning there. Identical instance should be fine for this one. I don't mind. Okay, so now we have this, right? So now we can load this one into our hand. Let me check the family name. So family 2. Okay, so load this one into family 2, and then this will be placed all onto all these. Okay, yeah, I don't mind. Click OK. So now we have this, and of course, if once you oh hell, so we need to hide 3 of the model lines, so you can see 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5, 6. So in this one, there's no, right? So that's fine. We can go back here. So no, don't delete. Okay, so we just and also if you click on this one, this is a divided path. It's not the one we want to hide. Okay, so let's select all the divided path for now, and then type HH. So now we can select the model line. So we just need to pick 3. Okay, so 1, 2, and 3. So we're going to just change them. Or actually, maybe you can just untick this visible. Maybe it works as well. So let's try. So load this one back into the family 2, override, and this, yeah. So I think it works, right? Is that right? Yeah, it's a little bit tricky to tell because they are all model lines. Let me just type VV, go massing, and uncheck the nodes. It might help a little bit, but still, so you can see this should be a the boundary member. So this internal one, so this should be thick. But yeah, you got the idea, right? So once we have those structure, the skeleton of this family, it's very easy to place all those form the sweeps, like right, or extrusions using just adaptive family. Okay, so this is the top and then the base part. So okay, so for the base part, I think we can also let's try. Okay, so I'm going to, because if you look at this one, the base is quite a circular shape, the top circular as well. Oh hell, something's quite not right. So this is in the middle, right? What do we have? Oh yes, it's just yeah, it's actually the hexagon in the middle because of the pattern. So this is confused. Yeah, it's a little bit confusing, but yeah, it's correct. Okay, so it's correct. So now let's model the middle, the base. So I'm gonna use just model some reference lines first. So I'll just use reference circle, drawn wood plan, set wood plan. You know what? I'm going to change this one to always show reference line, so it's easier to place reference plan. So you don't need to tab and switch between different reference plans. So reference circle, drawn wood plan, set wood plan, pick, and let's just this one, and create a radius. So we already have this radius here, so maybe I'll call this one radius R2. Okay, so maybe instance. Okay, and then we need another one. So this time I'm going to, so because we always have this one's the one with the height, so maybe we can just offset from this point up down. Okay, so down a little bit, so we don't need to create another parameter. Oh hell, sorry. Need to place a point onto that point first, so we can just offset it down. Okay, so yeah, maybe just type in -300. So if you want to, you can create a parameter so to control the gap between the top part and also the this bit. Okay, so then we can just create reference line, use drawn wood plan. Oh hell, maybe let's just change this one to always show reference plan as well, so it's easier to pick the reference plans. So pick and then create another one, so something like this. Okay, so we have another circle, so this time let's just create another radius. Oh, it's a bit hard to pick. So okay, so let's call it R3 instance, and okay, so now we have R2 and R3, right? To control that. So looks like maybe R2 need to be smaller and R3 need to be bigger. 1200, 1800, something like that. Okay, so with these we can let me think, how do we do that? Okay, so basically you can create a if we connect the line up and then do all these, so it will be like a sweep, but we of course we won't create. There are 12, I think 12 of them, and slightly different depending where you place. So I don't think we are going to model them 12 times. So if we can just create one adaptive family and place them, at least place that adaptive family 12 times. It's easier than model in place 12 times, right? So let's do it. So we're going to create a adaptive family for that part of that what do we call that, supporting structure. Okay, so adaptive. So in this, let's place a point, make it adaptive, and then we're going to place another point up a little bit, so that's the second point, right? And then we will need a third point. So this is the base, this is the top, and then this point will control the the distance between the middle and this point. Okay, so now, okay, so let me think. Sorry, I need to have a look, because I did this a couple days ago. Okay, so this is the adaptive I did. So let's edit family, so and see what. Okay, so first adaptive is in the middle of that circle. Second is the same in the middle. Okay, and then there's a radius. So which means we don't. Okay, that's fine. We don't need to create that radius in that family. We can control the radius 1 and radius 2 in this adaptive family. We just need to place it on the base middle point and the top middle point, and then with an offset. Okay, so that's fine. Yeah, I think I will probably just use this one, but before that I just need to go back. I'll close this one. I just need to go back to maybe I'll just close this one. I'll explain this one family to you, so don't worry too much. So this is the one we used to place those little member. So that's all good. So this one. Okay, so here. So we're going to just delete this one and also delete this circle as well, right? So we don't need them anymore. We're going to delete this point and also delete those two radius parameters. So let's delete and delete. Okay, so now let's go back to this adaptive family I previously did. So I'll explain to you what's going on here. Okay, so let me just HH this one for now. So I created this one, place a base. This is a point 1, adaptive point 1, adaptive point 2, and adaptive point 3. Okay, so the adaptive point 1 and adaptive point 2. So there's a reporting parameter to measure the the distance, the height is difference between point 1 and 2. Okay, so this is a height reporting parameter. And actually, what's this for? Do we need a reporting parameter? Okay, so that's reporting, negative reporting parameter. Yeah, I'm confused a little bit because I don't know why we probably don't need this. Even the hang on. Okay, so I know now I know why. Because I'm using the reporting parameter to control the offset. What's going on here? I think something's not quite okay. Yeah, that's fine because this also controls this one. So this is offset from this point. So yeah, okay. So that's all good. So yeah, so this is the point 1, point 2. So point 2 and point 3, these two controls the direction of this family, right? So you can see there's a line between point 2 and point 3, and with the line. Yeah, I think it's a little bit hard to explain this to you. Maybe I'll just I'll use this one and I'll share this family so you can just have a look. So basically let me think. Sorry, I just need some here. Okay, so I think the idea is to, because we're going to place 12 and yeah, so 360, right, divided by 12 equals 360 divided by 12 equals 30 degrees. So actually what I did is I trying to figure out, so if I here, if I connect this one and connect this, so this is a right angle. So this is a 30 degree angle, right, from this one. So in a right angle triangle, so if this angle is 30 degree, so this equals half of this. So if this R1, this is half of R1. So yeah, I just used this. So you can see if I select this one, this is the NHR1. So if I go to family types, NHR1 equals negative half R1, of course half R1 equals R1 divided by 2, right? So this is how I get the point on which if I connect this one, so we get 30 degrees. Okay, and then from this point and from this point, so this point all the way go up to the same. So in here I did the same thing. So you can see I connect this one and then find a point, use a point, use by intersection. So and then offset this one by half of this radius, half of this radius R2. So get this one, and then again just try to get another line parallel with this one, so and then intersect with this circle again. So you get this point. If I connect this with this center point, we'll get 30 degrees. So this is the idea. Okay, so which means from these 1, 2, 3 points, we can always get this at this point, go all the way up, connect back. How do we need, we don't need to connect back, so go all the way out, and then this is just a number relative to so the R2 is a a number relative to so of course you can see I use R2 times 1.2, but you can adjust that number if you want to. If you want wider, you can just increase that 1.2. If you want to narrower, so just reduce that number. So this will create a reference line. So from this base point, go up here, back here, down, and always keep that. If I connect this point and this point and this point and this point, so there is a 6-degree angle between them. Okay, so now if I type HR, so we see this is the profile, and also I didn't add any parameters to control it. If you want to, you can. Okay, so and also you can see I didn't add this one because if I add this one, so and when we repeat, it will overlap. Okay, so now let's load this one. Hope this is not too much, but you can always open this and have a look. So this one, family 2. Let's load this one. So actually, you know what? So I'm going to maybe hide this one. Just untick the visible, so it's not visible in the when I load this one in. But I'm going to select these lines to make them model line. Okay, so I'll select 1, 2, 3, tab. So make sure you don't. Yeah, sometimes it's good thing to select multiple, but sometimes it's not. Because in this case, I just want to. I'm not sure about this. Just click OK. Let's see what happens. Okay, so now we have. It's probably because we have this one, but that's fine. I'll just leave them. HR. Yeah, it's not visible. Should be fine. Let's load this one into family. Hang on, which one? Family 2. Okay, so load this one into family 2. So that's the 30 minutes mark. Okay, so now I'll try. So you can see place on here and place onto that point, and then the last one. So we're going to just place onto the midpoint on this edge. Let's have a look. Okay, so you can see. Yeah, it's a bit hard to tell, but I think I've added a parameter to control this point. Can't really. Let's have a look again. Edit family, because okay, maybe this need to calm down a little bit. Yeah, because if it's okay for now because it's all flat. So you can see it's overlapping, but once you have all those sweep and start to clash, right? So you can just maybe you can do this. So instead of directly place the second point onto this, you can also let me just delete that one. You can also place a point. You draw on world plan, set world plan, and just offset create a point and lower it. So maybe just here. So you will always have a point away from the top part, right? And then you can just create component here, and here. So because we are not placing this adaptive point onto nodes, we won't be able to use a repeat. So just need to do it manually. So it's not too bad. Maybe I'll just do this HH. Oh no! Once a HH, we can't place that. So that's fine. We just need to place one manually. Just 1, 2, and this time we go to the middle. Again, 1, 2, and midpoint. I'll probably just place 6 instead of 12 of them. 2, 3, another 2, 1, 2, 6, 1, last one, 2, 6 here. So now let's have a look. Escape. So you can see. Right. So if you want to 2, you can always. Oh hell! It looks like it's really hard to try to pick that point because there are so many, adaptive points from the adaptive family. So let's see. Yeah. So maybe change this one to always. So this way we can easily pick this point. So you can see you can lower this down, and then all these like this one adaptive file will adjust accordingly. Okay, so I think, and yeah, how to adjust the radius in this family. So I think because they are instance parameter, so we can select all once, and then we can change. So for example, I'll change to 1 meter. So this will see, and then the top bit, it's bigger, so that's fine. 1.5 you will see, so maybe lower, maybe 600, something like that, right? And then we can just reduce the height because we already have that height parameter. So just you can do it in here. So I think this is it. And then to change the radius, so radius here. So everything will follow, right? So you can see these are maybe they are too wide. I think okay. I didn't have that parameter in that. I used 1.2. So maybe we can just create a parameter. So for example, I'll just create a parameter called n instance and use a number, and then I'll just put in for a 1 for now, and type times n instead of 1.2. So click OK. That's all good. Click OK. Load this one back to family 2. Override, and then we will have the option to you can select all instance parameter here, so we can adjust this. So for example, number of 0.5, 0.9, like just like that. Okay, so I think this is it. I'll probably just quickly add some adaptive family with form, so at least it look nicer instead of just line works. And I will upload this family for you so you can have a play. Okay, so that's all. If you have any questions, please let me know. I will see you next time. Thank you. Bye.